Hello, Dumelang, Sanbonani, Molueni, and a warm welcome to the Maths Genius video tutorial series brought to you by SABC Education. In these tutorials, we help you unleash the mathematical genius in you by showing you key mathematical concepts and how you can master them for success like a true genius.
Today we're going to be talking about the laws of exponents. These are very useful when you're doing an algebra, simplifying expressions, when you're doing compound interest, and anything that has to do with powers. So it's very important that you grasp these concepts and be able to use them at any given moment. So the first one states that if the base is the same and the two powers are multiplying each other, then you're going to add the exponents. For example, 2 to the power of 4 times 2 to the power of 6. Because the bases are the same, it means that, and there's multiplication, so it means that we're going to add the exponents. So in other words, it's same base, multiplication implies addition, right? Same base, multiplication implies you add the exponents. So it's going to be same base, multiplication, so it's going to be 2 to the power of 4 plus 6, which will give you 2 to the power of 10. So the both conditions have to be met to say that the bases have to be the same and they have to be multiplying each other. If we had 3 here as a base, then this law doesn't apply, right? Same thing with the second law, which states that if the base is the same and there's division, then you're going to subtract the exponents, right? Let's use another example. 2 to the power, and let me not use 2 this time, let me use 3. 3 to the power of 10 divided by 3 to the power of 5, right? So, same base, division, subtract exponents. So it's same base, division, subtract exponents. So your answer would be 3 to the power of 5. So it's always important to ask yourself these questions. Is the base the same? Is it multiplication or division? Because if it's multiplication, you know you're going to add. And if it's division, you know you're going to subtract. So those are the two conditions that have to be met for you to be able to use these laws, right? Let's go on to the next one now. Now, whenever you've got a fraction as a power, whenever you've got a fraction as a power, then you know you're talking about roots, right? So, let's say you have 4 to the power of half. 4 to the power of 1 over 2. So that means that you're saying, according to the rule, you're saying 2 square root 4, like that. But we all know that the 2 represents the square root. And when we're talking about square root, we don't write the 2. So we just simply write it as square root of 4. And the square root of 4 is that number. We're saying, what number multiplies itself how many times? 2 times in order to get 4. And if you calculate that, you get 2. Let's try with a different one, because we've done square roots, you know square roots. Let's try a cube root. So, 8 to the power of 1 over 3. Because the power is a fraction, it means that we're talking about the cube root of 8, according to the law. So whenever you're given a situation in a bigger sum, and then you notice this, you can express this in terms of the root sign, right? So in this case, it's going to be cube root, the 3 of 8, the cube root of 8. And when we're asking what is the cube root of 8, we're saying what number will multiply itself 3 times in order to give us 8. And you will get 2 if you actually calculate it, because 2 times 2 will give you 4. 4 times 2 will give you 8. Therefore, 2 is the cube root of 8, meaning that 8 is the cube of 2, right? So 8 is the cube of 2, and 2 is the cube root of 8. That is how they are related, right? 8 is the father of 2. 2 is the son of 8. It's the same relationship, but if you look at it from this way, 8 is the cube of 2, and if you look at it from going the reverse direction, 2 is the cube root of 8. So that's how you apply law number 3, right? Now, going on to law number 4. If you have a power of a power, because remember, brackets in mathematics mean of. Brackets mean of. So you're saying you have a power already, and then another power. So this is a power of a power. So you're saying power times power, because of means multiplication. So in other words, you're saying a to the power of m times n. So as an example, right, let's say we have 2 to the power of 3, and then we have 6 out there. So we're saying 2 to the power of 3 is being raised to the power of 6. According to the law, because the power of a power, we have to multiply. So this is equivalent to 2 to the power of 3 times 6, which is 2 to the power of 18. So this is how you apply the laws. So if somebody says, simplify this 2 to the power of 3 to the power of 6, simplifying means remove the brackets. This would be the simplified version. So it's always important to be able to open your eyes and see when this happens, right? Then number 5. Number 5 is strongly linked to number 3. Because here you're saying a to the power of n, right? What is the mth root of a to the power of n? When you've got a fraction as a power, it means you're talking about roots. But now, you will find that combining 3 and 4, we have 5. I'll show you how, right? So, let's say, for example, you're asked a, right? Let me just use a, let me use 8, for example. 8 to the power of 2, right? 8 to the power of 2, and then they say, what is the cube root? What is the cube root of 8 to the power of 2? Meaning, what number will multiply itself 3 times to get 8 to the power of 2? Of which we know that 8 to the power of 2 is what? 64. So we're keeping it at the back of our minds that 8 to the power of 2 is 64. Right. So we're going to rewrite this using the law. Right? So the law says that it's going to be 8, which is our A. Our N is our 2. 2 out of 3, right? But how did we get the 2 out of 3, right? Let me show you. What we did was we took the 8 squared like that, and then we said to the power of 1 over 3. So what we did was we took the 8 squared, here it is, and then the cube root. Cube root from here, we know that it's going to be 1 over 3. And now, because we know that this is a power of a power, you're going to multiply these ones. So this is the same as saying 2 over 1 times 1 over 3, which is 2 times 1, it's 2. 1 times 3 is 3. That's how we got to the 2 over 3. So this law number 5 is a combination of 3 and 4. So it's always important to be able to identify it when it's used in an algebraic expression. Then number 6, it's fairly simple. It's a rule of thumb. Whether you go to the moon, whether you go anywhere, it's always going to be the same. To say that any number, no matter how big, no matter how small, if it's raised to the power of 0, the answer is always going to be 1. That is a fundamental rule. So don't ever think about anything else. Anything to the power of 0 is 1. Even if it's something as complicated as x plus y to the power of 0, the answer will always be equal to 1. Because this to the power of 0 as a rule will always be equal to 1. Then the last one, we're saying that a to the power of 1 is equal to itself. That's another fundamental one. So whenever you see to the power of 1, you know that it's the same as not putting a power. It's almost the same as the coefficient, where you know that 1a is equal to a, because that's a unity, right? It's just a unit. So a multiplied by 1, because you know 1 multiplied by anything will give you that amount, right? So whenever you see a power equals to 1, there is no need to actually write it. So make sure you do a lot of practice with these laws so that they are at your fingertips and you'll be able to use them when you do meet them. Thank you very much.
Thank you for taking the time to watch this video. Unleash your mathematical genius today. If you have any maths questions, you can post them for free on www.mathsgenius.co.za or email them to info@mathsgenius.co.za.